Let's delve into the essential interfaces that make up the foundation of the Java Collections framework. We'll explore what these interfaces are, how they are organized, and the common patterns for working with them. At the top of the hierarchy, you'll encounter interfaces like list, set, and map, which should be familiar from previous discussions. These interfaces are structured using inheritance, where more specific interfaces extend broader ones. The collection interface is the primary parent interface, which is extended by other interfaces such as list, queue, and set. Due to this inheritance structure, many methods are shared across these interfaces, as they all derive from the collection interface. Despite these commonalities, each interface also introduces unique behaviors that distinguish it from the others. For instance, list and queue maintain an order among their elements, whereas set prohibits duplicate elements. Although the map interface is part of the collections framework, it does not extend from the collection interface. Instead, it forms its own hierarchy but still follows similar patterns seen in other collection types. To better understand the framework, it's helpful to look at some common and concrete classes that implement these interfaces. These are the classes you'll use when creating instances of collections. Two of the most commonly used implementations are ArrayList and HashMap, which we'll explore in depth. Each implementation can be dissected into two main components: the interface, which defines the methods, and the implementation style, which determines how the underlying data structure functions. The naming conventions in Java collections often give away their nature. The first part of the name indicates the implementation style, array, hash, and the second part reveals the interface, list, map. This pattern is evident in names like ArrayList and HashMap. Sometimes, multiple implementation styles are combined, as seen in linked hash set. When you look at a matrix of these common implementations, it might seem overwhelming at first. However, don't be discouraged. If you thoroughly understand the collection interface, you'll have a strong grasp on a significant portion of the framework, as most collection types derive from this interface. This foundational knowledge makes it easier to navigate and learn the rest of the framework. Let's explore some of the key methods in the collection interface and understand their functionality. We'll be using examples assuming we're working with a collection of string objects. Adding elements. Add element. This method inserts a single element into the collection. It returns a Boolean indicating whether the collection was modified as a result. For instance, if you're using a set, which doesn't allow duplicates, and you try to add an element that already exists, the method will return false. Add all. Collection C. This method adds all elements from the provided collection to the current collection. It also returns a Boolean to indicate if the collection has changed. Removing elements. Remove. Object O. This method removes a single specified element from the collection, returning true if the collection was changed. Remove all. Collection C. This bulk operation removes all elements in the current collection that are also found in the specified collection. It returns true if any elements were removed. Clear. This method removes all elements from the collection, effectively emptying it. Retain all. Collection C. This bulk operation retains only the elements in the current collection that are also found in the specified collection, removing all others. It's the inverse of remove all. Inspecting the collection contains object O. This method checks if the collection contains a specified element, returning true if it does. Contains all. Collection question C. This bulk operation checks if all elements in the specified collection are present in the current collection. It returns true if the current collection contains all elements. Is empty. This method checks if the collection is empty, returning true if it has no elements. Size. This method returns the number of elements currently in the collection as an int. These methods are fundamental to interacting with collections, allowing you to add, remove, and inspect elements efficiently. As you progress, you'll also learn how to iterate over collections to work with each element individually.